Thank you. We're all really, really pleased. Little bit surprised because we didn't know we were getting nominated for this, so it all kind of came out of the blue. But it's really nice to be recognised for the work that Engineering Challenges takes to run. And my team is enormous. We have about 20 academics working together from across the departments. And every year we have about 50 PGTAs that work to deliver it. So we're an enormous group of teachers and teaching staff delivering it. There's a lot of work to lead large-scale interdisciplinary teamwork. It's quite enjoyable when you get to see the students kind of do these, get to build something and, see it. But I'm not going to lie, it's hard work. So it's nice to be recognized for our innovation and our work on the module. So Engineering Challenges started with the introduction of the integrated engineering program 12 years ago, I think now, at UCL Engineering. So it happened to align with when I first arrived at UCL, but I wasn't working on Engineering Challenges. So I sort of here about the same time, but I'm working as a postdoctoral researcher in biochemical engineering. And so I'm in biochemical engineering as they're creating this new curriculum from the ground up. So I'm kind of aware of what's going on. I've taught on like scenarios and stuff. So I'm like, project work is fantastic. And what I've done a lot of is taught and supervised master's students. By this point, I've got like a million thoughts about education and very few thoughts about research at this point, right? So I've got loads and loads of thoughts about education. I've been doing some outreach work. I've been doing some teaching. And I had really liked what the IEP was doing. So the aim of the IEP was to bring in this skills-based learning, to bring in this practical application. And Engineering Challenges is a key part of giving the students a space to practice and develop these skills. So I had really liked what was happening in the IEP. And all the issues I've had as supervising master students where I felt we really had to be explicit about how do you write stuff rather than just hoping you pick it up as you go along because we've made you do a written assessment. Actually going to talk about how do you structure a report, how do you structure a presentation, all this kind of stuff. And I've been like, this is the problem with my master students I've been like working on. And the IEP is designed to address some of those things. It's to give students those skill sets going beyond practical application of maths, all of that kind of stuff. So that's where Engineering Challenges sits in the IEP and how it kind of came in. Obviously, I think it's the most radical of our IEP modules because it's my module. But kind of saying right from the beginning of a student's degree path, we are going to put you in teams right from term one was quite radical at the time because there was this assumption that you need to have some technical knowledge before you can work in a team and work on a project. And what the IEP kind of showed with Engineering Challenges is you don't have to. There are ways to create projects where students don't need to have lots of technical knowledge, that you can embed it in degree programs, that you can show students stuff before you tell them the theory about how it works, and get them engaged with the process of building and creating stuff right from the beginning. I've always been interdisciplinary. My background is in organic chemistry. I moved into chemical biology and then the biochemical engineering department I was working on. Could you grow bacteria in automated platforms? Like my whole research career has been very interdisciplinary, very practical. So I'm really keen to work on the interdisciplinary practical module that is Engineering Challenges. That's how I got here, and that's where Engineering Challenges kind of sits in the program. Yeah, so the scale is really unusual. We're probably in the top 5 or 10 interdisciplinary team project modules in the entire world in engineering in terms of scale. It's fairly unprecedented to an extent, what we're doing. I'm not sure when I joined the IEP that I really conceptually understood what 700 students, which is what we were at when I first started, looked like and would require in terms of paperwork and that kind of stuff. And now we're at about 1,150, I think, this year. I'm not sure I can kind of conceive these numbers, but it's kind of a consequence of the interdisciplinarity. You want to bring multiple departments together, your numbers are gonna stack up really, really quickly. And one of the things we've been able to do is prove that you can do this at this scale, because there's a lot of a lot of people, when we first started doing engineering challenges, kind of assumed interdisciplinary teamwork really only works on like 30 students, 50 students, maybe 100 students. How on earth are you going to be able to do this at this scale? And I think what we've been able to show is, yeah, there's sacrifices we have to make, there's things we can't do at this scale, but actually there is no reason you can't provide students with these kind of experiences at this scale. You do not have to rely on a traditional lecture mechanic, but it just requires a lot of out of the box thinking and being willing to like leverage anything for teaching. Everything has like multiple different reasons why we've included it in the module. There's a lot of negotiation skill. I often get the reaction of people questioning my sanity when I explain how many students I work with. And then I do have a team. I do have a team of people. It's not just me. So engineering challenges is a kind of great module to be on because it's unlike most modules that you take in an engineering degree. So it's not about what you know as an engineer, it's about what you do. And quite a lot of what an engineer does is they try something and see what happens. In a controlled space, you're not building a bridge and going, I don't know what's going to happen. I hope it doesn't collapse, right? But like people build models constantly, prototypes. One of the things I love about engineering myself is the fact that no one knows what's happening. Every situation, every problem is new. You've got to come up with you can't kind of copy paste a solution. It's a new solution every single time because you've got to take into account the context and the users and the materials and the budget and all of this cool stuff. And so what we've tried to do is get a very basic version of that in engineering challenges to really just get students to kind of feel the possibilities of you can kind of do anything, but also to an extent the responsibility of you as an engineer have to make a lot of decisions around this. Now, when you make a decision about, what you're doing in engineering challenges, if you make the wrong decision, you can come to us and we can go, well, that was the wrong decision, but let me help you work out how to get back from there, right? It's in this controlled space where you can fail, but it's not catastrophic failure in that way. And because the module is very much about what engineers do, we don't necessarily need you to get a right answer or even a working prototype. If you get bad data, that's fine. If you can explain to us why your data is wrong and why your prototype didn't work, you can get first class marks in this module, right? Which for students who have, mainly experienced exams is a massive mindset change. And for some students, that's great because they're like, fantastic, I don't have to get the right answer, all this space I can work with. But for some students, it's kind of scary, and you can get why, hang on a minute. If I don't know what the right answer is, what am I aiming for? How do I know if this is good stuff, And that really the aim, certainly of engineering challenges, is to introduce students to that uncomfortable space of there is every possibility you can do, but you have the responsibility for making those decisions. And that's what being an engineer is. Some of them love it. Some of them are like, we read you did this. This is why we're here. We want to do this from the beginning, because we also bring in stuff like sustainability and ethics right from the beginning. They're like, yes, this is what I'm interested in. Some of them knew what it was, but didn't really understand how it functions. So there's a really big learning curve where they're like, we're enthusiastic, but this is hard work and a lot. And there's some students who, come in assuming engineering is applied science, and then like, why do I have to work with other people? And do kind of, I understand where the students are coming from. Hang on a minute, I don't know anything. I've been here for 3 weeks. How am I supposed to do this? And we're like, we know that. We've designed it. We can walk you through this process. So it is a big thing for the students, but the vast majority of them come through and are like, actually, that was really good. And we do a lot of work on guiding the students through the module because we know that they're new and that they don't necessarily know how to do it. And it can be really overwhelming to be told, now your marks depend on that other person and you've got to work with that other person to get this done. One of the things with engineering is you have to take into account the context. You are designing for different groups of people, you're designing for different communities, different spaces, all of this kind of stuff. And we know the more diverse a team is, the better they take into account a wider range of viewpoints. They better fit user needs, that kind of thing. Much, much better if you have a diverse team, you know. So how do we diversify our cohort? You know, one strategy is to kind of say these are all the different things that engineering is. But then if you get them into university and it's just maths and physics, you know, people can kind of go, well, why are we doing this? What is happening? You know, it's not obvious to me how I'm going to use these tools to maybe make a better iPhone or to, you know, better sanitation or any of that kind of stuff. So a lot of what we've done with the IEP is trying to bring what it is to be an engineer into the classroom space, to make it so that you're not always doing an exam. So students who find exams hard, I found exams really hard. I much prefer coursework as a student. You know, we're going to give you some coursework. Some modules are going to be 100% coursework. Some are going to have some, you know, some are going to be mainly exam. We're going to get you to do presentations, written reports. So if you're a great presenter, but your writing skills are not so great, we're going to give you the ability to develop those, but we're also going to give you assessments that you feel a bit more comfortable with, feel a little bit less comfortable with, that makes sense with what you're going to do going forward. So the idea underlying a lot of what we did in the IEP, we were trying to put this skills-based learning in, but one of the things we realized was we could make our curricula attractive to more students. We could make it work for a much wider range of potential applicants who want to come in and join us, and actually give them something that they don't kind of go, well, I don't really see myself in this. I don't really like doing that. And so that's been really nice to be able to provide students with those spaces, you know, to try something different and not necessarily stick to very specific ways of doing engineering education, and kind of show them how this is how you can use the maths to get where you want to be doing what you want to do.